Okay, I'm happy to introduce Professor Robert Durar from the Courant Institute of Mathematical Sciences at NYU. He's been head of department there. He's been associate director of the institute. He's been working with computers for the last 25 years. Developed a large number of different compilers for languages that you might never have heard of, like COBOL and Snowball. And of course, Ada. He's been part of the development of Ada, I think, since the early beginning.
Yeah,
is that correct? Yeah.
Yes.
And he is, at this point, the president and co-founder of the ACT, Ada Core Technologies company, that are implementing and distributing the NAT compiler you were using. And please,
okay.
Robert.
So, but I thought I'd give some historical perspective on Ada, trace a little bit of the history of Ada and where it is. So that's the past, present, and future. Okay, so time frame is, trace the history a little bit. Time frame is the 70s, and DoD's was and is one of the biggest consumer of information technology services, and they were spending at the time $4 or $5 billion a year on software. That's a long time ago. That was real money. I don't know what the figure is today. It's probably horrifyingly larger. So they're spending a huge amount on software, and they're having a heck of a time maintaining old software. And one of the problems they identify is that they counted over 450 languages that were being used. And these are, what was really going on was that everyone, that was a complete anarchy. You say, well, we have a new system, let's make up our own language to work on it, and DoD's got lots of money, we'll hire Intermetrics to write a compiler for it, and we'll have sort of some general fun. And PS, by the way, which I will appeal to our managers, we'll be the only people who know anything about this language, so we'll be the natural people who can maintain this system, no one else will be able to. It's very interesting to think that when you have a system that's long-term maintenance, like any avionics program, you're talking 20 or 30 years for that code, and in practice longer. If you can, a lot of the money and a lot of the profit comes from maintenance. So you have an interest in making basically unmaintainable software that no one else can maintain. The incentives are often very, very wrong. I mean, these weren't all junk languages in the terms of language design. But programming language is a field where everyone likes to make their own programming languages. I mean, thousands of graduate students have made their own programming languages, and lots of professors spend their time making new programming languages. It's fun. So they really decided a solution was to standardize on one language. What language? So the High Order Language Working Group was formed, and there were some unusual ideas put into action. One of the ideas, which was really unusual for the DoD at the time, and still doesn't come naturally, was to involve lots of people, involve academia heavily, involve industry heavily. Instead of doing things sort of in the club in a very closed way, things were done in a very wide open way. In fact, someone was asked, well, gosh, couldn't the Soviet Union make use of this technology? And the answer was, that's just fine. We intend this to be a freely developed technology which everyone can participate in, and yes, everyone can use it. So there were inputs from universities, industry, certainly the defense establishment. I mean, the goal of this language was really mission critical avionics, weapons systems. But I think the DoD was really in a mode of realizing that if they could bring in more use, they have economies of scale which will save them money. So, and international standards and scientific groups, ISO, IFIP. I mention IFIP because that's how I was drawn into it. I was, at the time, chairman of WG 2.1, which is the ALGOL committee developing ALGOL 68 at the time. And I got courtesy invitations from the other IFIP groups. So I got an invitation from IFIP Working Group 2.4, which is Systems Programming Languages, and they were doing one of the, an evaluation of possible alternatives for the new language, and I thought, well, I'm always happy to take a trip to Netherlands, why not? I came along, oh, it's quite reasonable, some interesting stuff is going on. That's how I got drawn into it 25 years ago, and I haven't managed to get out of it since. So the other interesting idea was to, instead of just saying, okay, you know a lot about language design, go design a language, it says, let's do what we do for other systems, which we've decided is a good idea. Let's make a specification and requirements document and figure out what we need, and then we'll design languages based on that requirements document. It's a pretty interesting concept. I can't think of it being done since or before that. It was really singular experiments. So the series of documents, I don't know if whether you've mentioned them in this class, but they started with straw man, which has a usual connotation of just sort of beginning ideas. And then there was a sequence of things: wood man, tin man, iron man, steel man, with the image of getting more and more hardened and precise. And steel man, they're really not language designs. They're very interesting documents to look at. You can go back, you can find steel man on the web. You can't find all the others on the web. I have paper copies of all of them, but they don't seem to have all made it to the web. But steel man is really the interesting one to look at. And it's so interesting to look at what you think, what requirements you might put into a programming language. So it's a final blueprint for a new single language. Now, at the time, the first step was to see whether any existing language met the specs, and there were some well-funded efforts to look at C, Pascal, and COBOL, and PL1 were the primary ones that were looked at. COBOL wasn't really seriously looked at, although I know that Gene Salmon, and actually I would somewhat agree, that probably COBOL came closest to meeting the specifications, but it was just culturally unacceptable to suggest COBOL for those kind of applications. So that was never very serious. But in particular, technical and how many people know COBOL well in this room? Anyone? See, and nobody. Okay. And now, what do you suppose are the two most dominant programming languages today? People almost always guess wrong. It's Visual Basic and COBOL still. Isn't that amazing? It just shows what a vacuum you live in. You can live in all kinds of vacuums, and in the academic environment, we tend to live in that vacuum. I actually talked to someone in the DoD in 2000 who was the person in charge of all data processing in the DoD, and he said to me, Robert, you're not going to believe this, but in the DoD there are some people still using COBOL. And he really had the idea that nobody else used COBOL. Well, that is definitely not true. But notice that C++, Java, C#, Eiffel were not really on the scene at that time. So since none of the existing languages really came close enough, say let's make a new language, and there was an international competition with 4 serious entrants. There's Green from Honeywell, Jean Ishbia, which is based on Lisp, which I think is spelled that way, but maybe someone correct me. It's a language that never got very much exposure, but was a very interesting language design. There was Red from Intermetrics, Blue from Softec, and Yellow, which came from Viet and the Pascal crowd. They were color-coded. In fact, if you on my shelf somewhere is the 4 nice colored manuals. The field was narrowed down. Blue seemed too strange, but it's kind of interesting, actually, if you're a programming language fan on at all. It's kind of interesting to go look at the Blue language design. It has some interesting things in it. Yellow, so the Yellow response never had a chance. It sort of said, well, we don't really think that Steelman makes much sense, and Pascal's good enough. We're willing to put in a few extra things, but not much. So everything came down to Green versus Red. The relative merits were discussed in many forums. There was kind of a mock trial in Pittsburgh at Carnegie Mellon between the two languages. There's an interesting, if you go back, you can find an interesting article by Dijkstra in SIGPlan, severely criticizing both of those languages, but actually if you read it, he doesn't really have very fundamental criticisms of them. Anyway, finally the winner was Green, which was interestingly developed in France, and there was no, it's interesting to remember, it's just not just France particularly that I'm referring to here, but there was just no concern that it was developed outside the US. That was part of the emphasis on internationalization. And so Green was announced the winner. It was renamed Ada, which, as I expect you know, is named after Ada Augusta Lovelace, Countess of Lovelace, who is Lord Byron's daughter, a remarkably colorful person. It's kind of fun of you. There are a few colorful biographies of Ada, and they're worth reading. She's a very interesting character. But she did the programming, some of the logic development for Babbage's difference engine. Actually, her real interest in that was she was an inveterate gambler, and she figured that devices like Babbage's difference engine might be useful for picking winners on the horses, and that's why she was interested in it. One of the things about DoD is they opened up the process, but they poured lots and lots of money into it. Lots and lots of money. One B-2 bomber cost $2 billion or something like that. So you don't have. So a small fraction of one B-2 bomber pays for a lot of stuff. So I don't suppose that the total Ada development was 1/10 of that amount, but it really did mean there was substantial funding. A lot of university work was funded, and a lot of work in industry was funded, in particular the test and example programs. So contractors were paid to do significant programming in the proposed language at various stages to get an idea. There's a formal test suite developed, the ACVC tests. An early version was completed in Ada 79. And then there was a sequence of efforts. We were very much involved in trying to implement Ada 79, showing there were some significant problems in it. And the result was the proposed Ada 83 standard. Standard was issued in 83. First validated compilers came a couple of months later. That was the NYU Ada Ed compiler. That had actually had its genesis as really a specification of the language rather than something you could actually use for real applications. But then commercial compilers appeared soon after. About a dozen Ada compilers companies appear. Lots of venture capital and banks, you know, DOD is rich, right? I remember, just a side note, I remember visiting Bunker Rainbow in I can give the dates, 1973, and we looked at this wonderful display terminal, which was really quite impressive for the time. You know, amazing resolution, back projected maps, and someone says, how much does it cost? $380,000. Oh, and then the guy said, almost as explanation, well, it's for DOD use. So, in those days, there was a real feeling of infinite money. That, I will note, that feeling has gone completely from the DOD. You really don't run into that. There's a much more consciousness of doing things efficiently and reliably. So system houses were investing large amounts. DEC did their own implementation. Companies like HP, Unisys all paid millions of dollars to acquire Ada technologies. Everyone thought, the DoD mandated that Ada be used for all development. I mean, there was a Ada mandate signed by the Secretary of Defense that says, thou shalt use Ada for everything. The only trouble is there wasn't really an or else. Or else what? We won't pay you? That's never happens. You know. So the Ada mandate was widely ignored from the start. I heard of one case where a program was supposed to be delivered in Ada, and they delivered it in assembly language, essentially uncommented assembly language. The final system had many, many serious defects. It was deployed anyway. I believe it was a system for control of nuclear-tipped torpedoes on submarines, but the Navy had to deploy it. It was too embarrassing not to deploy it. There's a long history of sort of deploying things and then fixing them in the field, which is not, sounds terrible, but it isn't altogether terrible, because sometimes you don't really see the operational problems with complex systems until they are deployed. So it's not entirely terrible to do that, but of course it's led to a lot of disasters and semi-disasters. But the result of the mandate is Ada does become a dominant weapons system programming language. And the competition as time develops is C and C++, Smalltalk in the COBOL area. The 400 junk languages really do disappear under the influence of the Ada mandate. So mission is achieved, at least partially, of blotting out excessive use of mysterious languages. Programming languages always borrow ideas from one another. There's so many programming languages. There must be thousands, tens of thousands, maybe even hundreds of thousands of programming languages. So there are very few brand new ideas. Mostly what you're doing is putting together a combination of ideas with some general focus. I mean, in the case of Ada, the focus was to write a language that would be suitable for embedded and highly critical real-time programs. Although, even if there's a focus, any of these languages tends to be somewhat a general purpose. It's hard to design a language that really is only useful for a certain, very specific process. So Ada drew from many sources. The elaboration of modules comes from Algol 68. I'm always kind of pleased that some of the module design came from Algol 68, because that was my contribution to the Algol 68 effort many years ago. The tasking came from theoretical work based on CSP from Hoare. The typing system was really developed from Pascal, where it proved very successful. Here's a very interesting but not similar 67. And why is that interesting? Well, everyone, in the last decade, everyone has discovered object-oriented programming as an important, maybe the important, maybe even the only important, depending on your level of your fanaticism, way of programming. It's not at all a new idea. Simula 67 is an object-oriented programming language that actually really does things right, because objects are all concurrent, and the communication between objects is message passing in an asynchronous cooperative manner. It's a very nice object-oriented language. But the people who designed Ada had a lot of experience using Simula 67. They'd written the Lisp compiler, and they decided that object-oriented programming was an impractical paradigm for large programs. So that's sort of an interesting note of history. Certainly wasn't that. It wasn't that it wasn't there because it wasn't known about. It was because it wasn't there by choice. Certainly many language ideas have been drawn from Ada. Yeah, here's an interesting note. Ada 83 depended heavily on the note of idea of generics, which is these sort of frameworks which you then instantiate with different types. And C++ depended heavily on object-oriented programming and dynamic dispatching. They're actually, that's two sides of a duality. It's sort of interesting. If you can sort of show that any programming problem that can be approached from one can be approached from the other. It's an interesting question in a language. Do you try to keep things super simple by reducing the number of concepts to an absolute minimum, or do you let competing ways of doing things come to the language? People often complain that Ada is too complex. They make that, if they're being fair, they should make that complaint even more energetically about C++. And I came to realize as we were working on Ada, that simple is an interesting word, because simple for who? Simple for the implementer. You know, we don't want lots of fancy features. They're hard to implement. Simple for a guy writing a textbook. Simple to learn when you're first learning a programming language. Simple for the formal guy who wants to define the language precisely. Or, what might be the most interesting place to look, simple for the applications programmer writing a program. Well, let's just take an example. Exceptions are a huge pain in the neck to implement. Any language implementer would be happy to boot them out. They're also, I think, if you're first learning the language, a little tricky to understand. I mean, it's not an obvious concept, the idea of exceptions and how you use them. But for an applications programmer writing a large critical program, they really simplify the application. And having to do, I mean, imagine the following. If the only way in a language of recording exceptional conditions was for a function to say, I terminated unsuccessfully, then every function which called every other function would have to be saying, did you terminate successfully? Oh, you didn't. Well, I guess then I won't terminate successfully. And the whole program would be pervaded with junk of that kind, compared to a low-level routine saying parity error, raise parity error, going up to the top of the program and saying parity error is serious, we have to restart the program. You know, we don't want to test for parity errors all over the program. So that's a nice example of why simple and complex are tricky words. And one of the things we did is I started to insist that anyone who used the word simple had to say simple for whom. And that was a very helpful language design. So anyway, interesting evolution is C++ eventually added templates, which are really a sort of very much drawn from the idea of generics, although interesting compare templates and generics for a moment. Templates are much more powerful, but much more out of control. In an Ada generic, you can tell at compile time whether the thing is safe and properly programmed and will work in all instantiations. You can't do that for templates. It's kind of, well, try it and see, and maybe it will work and maybe it won't. And it's hard to describe when it will work and when it won't. That's an interesting issue in programming languages. Do you want to make it super easy for the programmer to do anything, including shooting themselves in the foot? Or do you want to place lots of constraints on the program so that they're less so they'll have to work harder to shoot themselves in the foot? And of course, Ada very much takes the second position. Someone at MIT once described Ada to me as the police state language. Lots of rules, and which if you break them, you get punished for. So anyway, Java. Java has an interesting history. It was originally designed as a safe language for embedded systems, the same exact design goal as Ada. And then Sun decided quite late on in the cycle, maybe we can use this for web-based mucking around. And they changed the direction of Java. The interesting irony is, where is Java successful? Small embedded systems, like particularly cell phones. Cell phones has been the most successful application of Java. But actually, given that Java had the same general directions, borrows quite a lot, certainly not syntax, because it borrows its syntax from C. But although Java looks like C, it's a very different language, and it has many of the sort of safety views that are in Ada. And if you look at Ball and Pascal, that's a Delphi system. It borrows modules from Ada. I'll make a little comment on Pascal. We had a side comment. About 2 years ago, we were having the usual discussion. What language shall we teach in beginning computer science at NYU? And we were previously teaching Pascal. And there was a gang that wanted to teach Java. Nobody knew anything about Java, but it seemed a fun idea to teach Java. And one of the guys who was teaching Pascal said, well, one of the problems is Pascal isn't used in industry. And I said, well, A, how would you possibly know whether that was true or not? You don't know anything about what's used in industry. Remember our little poll about COBOL a moment ago? And I said, besides, it's completely false. You know, please go to the Borland website. And we're living in New York, right? One interesting item you'll find is that the Metropolitan Transport Authority of New York does everything in Pascal. I mean, top to bottom, they're Pascal shop. Actually, that's no longer true today. The signaling system for the new subway system is going to be in Ada. So that's an interesting little bit of history there. But I say, not much new under the programming language skies, and Ball and Pascal borrows the module notion from Ada pretty heavily. So a little bit of an Ada 83 retrospective. Ada 83, from a technical point of view, proves remarkably effective, and you'll find there's a lot of technical literature to test this. In achieving some of its goals, improving reliability by finding problems earlier. There's an interesting study from IBM, it's quite old at this stage, which looks at the cost. What is the cost of a bug that you find immediately because the compiler kicks it out? Now, what's the cost of a bug that the compiler didn't find, but you find at runtime pretty easily, but from initial testing? What's the cost of a bug that you don't find from initial testing, but the integration testing finds it? What's the cost of a bug that the integration test missed, but beta testing finds? And finally, what's the cost of a bug that's in the deployed product? And roughly, it's a factor of 10 each time. And that's quite a lot of factors of 10. So there is a tremendous gain in finding things earlier. And one of the things, this is something you have a better perspective on if you've programmed in several languages. One of the things people say about Ada is, it's a pain in the neck getting an Ada program past the compiler. It complains about all sorts of stuff. It's really annoying. I must say, though, once it gets past the compiler, often works right the first time. Well, that's an interesting comment to be made. Now, big complicated programs never work right the first time, but still, that phenomenon that you can find things at compile time is an important one. It tends to encourage a disciplined programming style. Now, that's a sort of part of culture. Programming languages tend to come along with the culture that goes along with them. It's not wired into the definition of the language. But you know, C programmers tend to be sort of closely associated with some hacking community that likes to fiddle. You know, a C programmer is very happy to say, look at this neat piece of code, isn't that clever? Which I always regard as disaster, basically. You know, if you say, here's a neat piece of code, isn't this clever? You're looking at a piece of code that's obscure and had better have a very heavy burden of justifying itself. Stupid, clear, easy to read code is what we're looking for. Sometimes you have to do tricky things. You're driven to them by extreme requirements. But mostly unclever code that's clear to read, clear to understand is what we're aiming at. And so that orientation to quality certainly seems to be something that has historically grown up with Ada. And one of the most important conclusions we can make from a programming language point of view, the package model is very attractive. Being able to divide things into packages and being able to separate the package specification from the implementation is a very important achievement. I I would say one of the biggest weaknesses of Java is that it turns its back entirely on that. Well, that's not quite fair, because Java does, but Java plus Java doc redresses the difference. So if you really commit your Java programming style fully to using Java doc, you can retrieve some of that. What about C? Well, for those who've messed with C, you can use C headers in a way that's entirely analogous to Ada packages, but nobody does. Not in real life. They tend to put the minimum stuff they can in a C header that they can get away with. So again, it has partly to do with the culture that comes behind it. The type system, and particularly separation of scalar types, is effective in preventing silly errors. I mean, it's really handy that the compiler won't let you add a file number to a column number. I mean, such an addition can never make sense. And if you've made them separate types, you'll find that kind of error immediately. And you know, one of the frustrating things about programming, I have a little poll. You know, that's I usually say, who finds programming fun? You know, let's put up your hand if you find programming fun. Oh, yeah, we have a fair number of hands up. Now I want to say, who finds debugging programs fun? Now I see there's a fair number of people put up their hands. Now I have an observation that for the people who find debugging, I know some people find debugging programs fun. In fact, I think for some people it's sort of like role-playing adventure games. You know, there's a bug lurking in this package. Aha! You know, they kill it. But so I want to observe that if you really like debugging, then that's too bad, because we'd like to really spoil your fun and make it unnecessary to debug programs. And that's one of the things, if I go to a room of Ada programmers and I ask how many people use the debugger all the time, it can be half and half. If I go to a room full of C programmers and I ask how many people use the debugger, everyone does. How could you not? So that's an interesting little poll. Here's my profile. I love programming. I like playing role-playing type computer games. I hate debugging, so there. And so languages which help me avoid debugging are attractive to me. And so many bugs come from just stupid things. I mean, isn't it incredible that you can just mistype the tiniest thing and it has this horrible effect? There's an urban legend that that the Venus probe was lost because of a comma instead of a period in a Fortran program. And you can indeed write up a Fortran program where it's actually the difference between this do 10 I equals 1.6 and do 10 I equals 1,6. This is an assignment of a floating point value to the variable do 10I. Blanks don't mean anything in Fortran. And this is a loop that runs through statement 10 for I going from 1 to 6. And it's just a comma and a period difference. And in the bad old days on line printers, you often couldn't tell commas from periods if the printer ribbon was a little bit dubious. So that's an urban legend. However, it is true that that bug got through to the final integration testing and was caught in the last possible moment of simulation. While, incidentally, the Venus probe was already in flight. I don't know if you know this, but a remarkable thing about these kind of long-range NASA missions, you don't need to write the landing software when you send it off. It's years before it arrives. You have plenty of time to get it ready. And that's really the way it's done. Now, that's a hard deadline, right? That's a deadline that absolutely must be met. There's a certain style of programming called clean room programming, in which you do the following. The development team writes the program, they're never allowed to run it. They deliver it to the integration testing, and who looks for final problems in integration testing. They are never allowed to run your program. Now, you've all done some programming, probably enough to be amazed at that idea. How could you possibly deliver reliable programs that you have never even run once? Well, the answer is you need very different styles of programming, where you program in a very disciplined style. You use formal mathematical methods to reason about your program, really look at the code carefully. And Ada fits that kind of model more easily than other programming languages. But, I have a big but. And part of the trouble is people tend to hype things, and I think Ada was hurt by this kind of hype and should be avoided. So you hear silly statements. Ada programs are guaranteed to be portable, which is complete nonsense. It's perfectly possible to write non-portable Ada programs. In fact, it's kind of vital to be able to write non-portable Ada programs. Yeah.
What is portable?
What is portable? That means that you can take a program which is written for one computer and without any changes run it on another computer. I mean, suppose, look, we've got a Mac and a PC here. So a portable program should be able to be moved over from this machine to that machine without any changes in the source code. And that can be achieved in a variety of programming languages. It's easier to achieve in Ada. But one of the advantages, one of the important things about Ada is in real life systems, I mean, you know, if you're making the F-22 fighter, you don't say, jolly good, we'll port over the F-15 fighter software and makes us few modifications. That's not anything like that. And in fact, the Ariane 5 disaster came from trying, improperly trying to do that. They moved over a chunk of Ariane 4 code for what they thought was pretty similar stuff, and it turned out that the physical parameters are so different. See, I think the interesting thing about avionics software is that it's really much more than just a sort of mathematical algorithm. You're really at the barrier of physics, and you're dealing with the real world, and you're dealing with things that go wrong. And so the code has to really be, the code is often very integrated with a particular physical system. And so the notion of just porting code to another environment isn't always important. Another thing is the sort of idea Ada programs are guaranteed to be high quality, and that's nonsense. And people can succeed in writing junk code in any language if they're determined to do so. And equally, if they're determined to do so and competent, they can write high quality code in other languages like C and C++. Sometimes one of the valuable things you get from studying Ada is you learn some principles of Go coding that you can port to other junk languages. So there's a little bit of editorializing, which I should really avoid. But no, seriously, you can write, if you're writing C code and you have the same quality emphasis, you can greatly improve the quality of your C code. But Ada doesn't tend to encourage and promote quality. And the other thing is Ada programs are guaranteed to be easier to maintain, and that's not true either. But again, it encourages it. And I don't know whether you've been exposed to this. So nobody's allowed to answer this question who knows the answer from some other area. But so if you don't know the answer, just guess an answer to how many lines of code, of source code, does a professional programmer write per day? In the context of a safety critical program, that's one on which human life depends and has to be really reliable. So you just have in mind a figure, guess a figure from your experience. I'm sure that no one will guess the right answer. It is about 1. And that's about 1/10 the productivity of ordinary programming. Ordinary programmers in ordinary applications can do 10 to 20 lines of code a day. Now, you know, that's kind of weird because, especially in schools, well, I can bash off. If I've been to a late party on Saturday, I can still bash off 1,000 lines of code to pinch for hand in on Monday if I have to. But that's very misleading for a few reasons. One is you've been thinking about those lines of code in advance. So a little bit you're operating like Mozart. There's a nice scene in Amadeus where the score for Magic Flute is late, and they kind of say, we need the score. We're starting rehearsals on Saturday, and Mozart said, it's finished. Oh, thank God. He said, where is the score? Up here. The rest is scribbling, he says. So that's part of the phenomenon. You've thought about it, and that thinking time counts. And the other is, you know, you do an assignment quickly for class, it manages to run the sample problems, you hand it in, it gets a B+, and that's the end of it. But in real life, you know, that code has to be put into production mode, and the whole business of taking, say, the basic code for a fighter jet to actually be willing to, a pilot being willing to press the throttle forward and take off in it is a long and hard road, a very long and hard road. And that's what really takes up the effort, not just the actual coding is a small part of it. So programming is enormously expensive. I mean, we really spend a huge amount, and very unpredictable. I mean, that's the other thing. Programmers are really a menace when it comes to saying, when will this be done? And they give you unrealistic times. And there's a problem in all areas, but particularly bad in software. So even if we get a little advantage in programming, that's worth a lot. So, you know, if you were to be able to convince someone effectively that this technology will save you 10% of your programming costs, that quickly translates into millions of dollars. If I could show you that a particular programming technology reduced risk of schedule variations, that quickly translates into millions of dollars. So I think it's rather clear that, that Ada can provide that kind of assistance in this specialized area, which is high reliability critical systems. I mean, perhaps in all areas, but concentrating in that area for the moment. Did Ada take over the world? Well, no, it didn't. It didn't come close. But it achieved significant success, particularly in aerospace applications. Most military planes, the avionics, are Ada-based. Most air traffic control systems in the world use Ada. The commercial aviation, it's had real success. The Boeing 777, probably a lot of you have flown on that plane. That's an all-Ada plane. That's not quite true. The cabin entertainment system is in C++, and it's very unreliable. But I don't think that's, to be fair, I don't think that's really the language choice. It's because it didn't seem critical, a critical application. Of course, if you're on the plane, it's quite critical. But, So Ada in the 90s, there was a well-funded update to the language. Same high level of involvement of all segments of the community. Major additions were object-oriented programming. Some other technical things, but the object-oriented programming was the major addition. I will make an interesting comment here. Nobody knows how to use object-oriented programming in the context of safety-critical programs. There have been several big conferences on that subject. Nobody knows. I can tell you roughly why. Object-oriented programming is all about doing things very dynamically, so you don't know what's going on. When you make a call, you don't know what method's going to be called. It depends on dynamically what class of thing you're dealing with. That's the whole point. That's very bad in safety-critical programs. You want to know exactly what's happening at all times. So there's a fundamental conflict there.
I was wondering if you could explain what object-oriented programming is.
Okay, object-oriented programming, in this context, it's the idea of having many different objects lying around in your program. And if you say print this object, each object knows how to print itself. So that print might do a completely different thing depending on what particular object you're looking at. And it's a very popular style of programming, but I can tell you there are no significant avionics applications that are written that way, because we just don't know, we don't even know it's useful in those contexts, let alone how to implement it properly. There's an interesting question. Are military aircraft safety-critical applications? That's not an obvious question. I mean, a safety-critical application, say in commercial aviation, the whole idea is that nobody should die. Well, that doesn't quite apply to F-22s. You expect them to be shot up, and you're willing to trade performance for safety in those applications. I mean, goodness gracious, you know, these planes like these F-22, like the advanced fighters with unstable airfoils, which if the computer doesn't correct immediately, they disintegrate rapidly within milliseconds. I mean, I don't know if you want to fly around in one of those unless you were very sure of the software. Certainly if your concentration on safety-critical principles, you would never design a plane like that. I don't think they're ever going to design commercial planes that have those kind of characteristics. Nevertheless, the trend is to regard more military systems as safety-critical and to apply those kind of constraints to them for all sorts of obvious reasons. Another interesting thing is that GNAT appeared, so it was the first free software thing. The mandate was abandoned by DoD in the 90s, sort of a recognition of reality. It's supposedly replaced by a process in which everyone chooses the best language for the job, blah, 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 which, as I mentioned above, completely bogus. But by now there are many Ada enthusiasts embedded in the military and defense contractor network and elsewhere, and Ada continues to be extensively used. But for both new programs, C-130 AMP, parts of the F-22 still are legacy code that are using Ada. JSF is using Ada for new components. So it's all around the place still. And one thing we sort of recognize now is no point in reprogramming reliable legacy Ada into language XXX for the sake of it, just as there was never a reason to program reliable XXX stuff into Ada, which did happen under the influence of the mandate. Anyway, in this decade that we live in, it continues to be used in important new programs. I mentioned the C-130. Major companies are renewing commitments to Ada. Rockwell's chosen Ada 95 as its only programming language for the AMP, a little stack-based chip that is everywhere in planes. Any plane you go into has so amps behind the meters, and it's one of these ubiquitous little chips. And usage continues in the commercial arena, which is always interesting because, you know, if something becomes DoD only, that's worrisome to the DoD and worrisome anywhere. The Boeing Dreamliner, the 787, we know about. These are mostly GNAT things because those ones happen to know most about. The new Airbus Jumbo Jet is using Ada extensively. Eurospace uses GNAT for air traffic control systems in Europe. There's a new version of Ada being produced now. Ada 2005 is the target date. Relatively minor updates, but continuing the principle of borrowing from other languages. A very successful notion in Java has been the notion of signatures, which is sort of it says that this package can implement this kind of functionality. And that will be is going to go into 2005. In C++, you can have the equivalent in Ada of two package specs, each of which depend on the other. A big no-no in Ada, but useful and reasonable in some cases, and that's accommodated. So, will Ada take over the world? No, it won't, but it'll be around for a long time. Here's the thought. In this area, we tend to think, you know, oh, Windows has taken over the world. No, it hasn't. There's lots of stuff done in, not in Windows. Mainframes have disappeared. No, they haven't. There's lots of mainframes being sold. I mean, it's true that mainframe sales are roughly flat now. They're no longer declining. But they're flat. They're not declining. They're flat. So there's mainframes are around. PL1, I said, was a failure. Doesn't mean there's not lots of stuff being done in PL1. So technologies live on in small, in sort of specific technical areas. And here's a little thought. I mean, BMW has only a tiny fraction of the automobile market. We don't usually think, oh, that means BMW is a failure. But we do tend to have that feeling in the technical computer market. And it's an interesting effect. So Ada will have a significant niche in large critical applications. And that's kind of a nice niche to be in because systems are growing in complexity all the time. I mean, it's not unusual for systems now to have millions of lines of code. Remember my figure of 1 to 10 lines of code a day, depending on whether it's safety critical or not. Do some arithmetic. That's an amazing bit of arithmetic to do. So those are huge systems, and as I mentioned, avionics applications in particular being increasingly regarded as safety critical. People are finding that they are being forced to certify applications, which means go through this formal process of showing your application is completely reliable, where they weren't asked to certify before. And the FAA certifiers and the DoD certifiers are getting serious. You can't pull wool over their eyes anymore. They really, really insist that you go through all the process. So both of those things augur well for Ada. There's still hot competition in the Ada world, and you have different Ada vendors competing with one another. And it's sort of nice that I think the Ada environment is a particularly good example of effective example of free software competing. So those are some general observations on Ada. Our company is growing steadily, has been success. We're just about to celebrate our 10th anniversary. Our business has been growing steadily. It's sort of amazing. Well, the rest of the computer industry was going like this. We were going like that, which is a very nice curve. And so we see the Ada industry effectively growing. This is a technology which really meets a need, and there's quite a band of people who are committed to that. So, and I don't expect Ada to take over the world, but I do expect to have an important niche. So that's, I'm happy to take any other questions.
Any questions for Robert?
It would be nice if you could talk about certification issues, costs on Ada versus C or C++.
Yes, I mean,
a sense of why.
Yeah, well, I'll answer that in one rather quick way. A company that's a primary leader in certification is Praxis Critical Systems in England, and what they've been using is a subset of Ada called Spark that's particularly effective for. You can't certify full C++. You can't certify full Ada. You can't even certify full C. They just have too much junk in them. That subset of Ada seems to be a very successful subset. C++ is really difficult to subset effectively for critical purposes. Even C is tricky. Mistra C is an attempt. So yes, when it comes to certification, Ada has real advantages. Another example of that is Vericel, is the company in Boston that has big business certification. They far prefer, if I prefer to certify Ada, and it shows, it costs less. That's just a way of making that point.
Okay, thank you very much once again.
Okay.